Hi students, I'm going to work out this question with you. This is from the textbook on page 15, number 4, and this is the iceberg question, and it's a challenging question. It's also a really good example of how to take a bunch of different conversion factors and be able to do a unit conversion, unpacking a question, and setting up a unit conversion using this method of what I want equals what I have times what I know. And really the first step in approaching this question that we're going to look at is, what do I do with all this information, right? What is the want? What is the have? What is the know? So that's what we're going to do. We're going to work through this question together. I'm going to follow that process, what I want equals what I have times what I know, and I'm going to figure out my conversion factors, and then I'm going to make a plan to go from the units that I have to the units that I want, and then we're going to follow that plan as we set up our calculation. So let's start with part A, and this question tells us that it requires 334 kilojoules of heat to melt a kilogram of ice. Okay, so this really is a conversion statement. It tells me that if I have a kilogram of ice, the requirement to melt that is 334 kilojoules of heat. Now we could write that in a couple of different ways. I'm going to write this, and I'm going to use a blue pen here for my conversion factors, and I'm going to write this like this: 300, and I guess this is a black pen. 334 kilojoules is equal to a kilogram of ice. Now I could take this statement and I could write this in two different ways. I could write it, if needed, I could write it with the kilojoules on the top. So we could write this as a conversion factor like this. So 334 kilojoules per a kilogram of ice. That's one way we could write it. And we could also flip that around, take the inverse and say, okay, well, if we have a kilogram of ice, then 334 kilojoules of heat is required. So any conversion factor or any conversion statement can always be written in two different ways. We could always have the units in the numerator or the denominator. How we use it in a calculation will depend on what units we need to cancel. So I like to write it as an equal statement because then I can go ahead and set it up either way depending on what units I need to cancel when I'm actually doing my calculation. But this is a little easier to work with than a word statement. So instead of using this right here, I can write this out as a nice equal statement, and then I can work with that. Okay, good. So now let's read this question. It says, the largest known iceberg has a volume of 3.1 times 10 to the 13 meters cubed, or cubic meters. Okay, right away, let's start to unpack this question. Let's go ahead and write that out. So it tells me that volume is equal to 3.1 times 10 to the 13 meters cubed. So that's the volume of an iceberg. How much heat was required or is required to melt the iceberg if 1 cubic meter of ice has a mass of 917 kilograms? Okay, well, again, let's unpack this. The question is saying how much heat. So it's really saying what we want from this question is to figure out how much heat. What units are we using for heat here? Let's go back up here for a minute. We're using kilojoules as a unit to measure heat. So what we really want here is how much heat, or another way to say that is, what I want is going to be the kilojoules of heat. How many kilojoules of heat are required to melt this iceberg here with a volume of 3.1 times 10 to the 13 meters cubed? Once you kind of understand where you're going with this calculation, it's a lot easier to start to set things up. So what we have is a volume in meters cubed, and what we want to know is how much heat is required to melt it. Okay, then we also have this piece of information right here. 1 cubic meter of ice has a mass of 917 kilograms. That's clearly going to be important to us at some point. Again, let's write that as an equal statement just to simplify it. So let's go ahead and do that. Let's say, well, 1 cubic meter, 1 meter cubed, is equal to 917 kilograms. Okay, this is a cleaner and easier to work with. So again, I have another conversion factor. So what I really have is the volume in this question. Okay, what I have is a volume, what I want is kilojoules of heat, and what I know are these two conversion factors that I wrote down for myself as I was unpacking my question. Let's put those nice and carefully together here. So let's say, okay, here's one of the things I know. 1 meter cubed is equal to 917 kilojoules. Let's clean that up here 1 second. 917 kilojoules. Okay, so that's one thing that I know. That's a conversion factor. The other thing that I know was up here, 334 kilojoules, okay, is required to melt a kilogram of ice. So that's equal to 1 kilogram of ice. And we could even take the word ice off to keep that even more straightforward for ourselves. Okay, so kilograms of ice. Okay, so I have two conversion factors that are going to be useful to me, and I'm starting to see where I'm going. I know that I'm starting with a volume of an iceberg in meters cubed, and I want to get to kilojoules of heat. So the next step is, let's set up our plan. And you know what, if you are already seeing exactly where you need to go with this calculation, that's great, and you can go ahead and jump ahead and try this out for yourself. But if you're still feeling a little bit lost, let's stay with me, let's work the plan out. So remember, we're always trying to go from what I have to what I want. So what I have here is going to be ice in meters cubed, right? So we've got meters cubed of ice. Okay, and I want to get to, eventually I want to get to kilojoules of heat. I'm going to write kilojoules of heat over here because I know I can't get directly there with one conversion factor. Well, let's look back at our conversion factors, and when I'm looking at my conversion factors, I'm looking at the units in the conversion factors. So, you know, here I'm starting with meters cubed. Well, this first conversion factor right here deals with units of meters cubed, and it allows me to go from meters cubed to kilograms. Okay, so that's not kilojoules, but it is a step on the way to kilojoules. So I've got one conversion factor that gets me from meters cubed to kilograms. And then over here, I have a conversion factor that gets me between kilojoules and kilograms. So there's my plan right there. I need to first go to kilograms of ice. And then once I'm in kilograms, I can use this second conversion factor here to get from kilograms to kilojoules. So I'm going to have two conversion factors, two steps in my calculation, and I can follow this plan now to set up my calculation. So once in the beginning, when you're getting used to unit conversions, setting up your plan is helpful because it guides you, and you can just keep looking back to that plan. You can even go a step further, and I often will say this to students: if you're feeling a little bit still sometimes lost when you're setting up your calculation, what you could do is take these conversion factors that we've written above here where we said what I know. We could take those conversion factors and write them right over top of the arrow in our plan. And then we can really just follow our plan when we're setting up our calculation. So, or we could also number our conversion factors. I'm going to do that now just for the sake of time. So in step one, this is going to be my first conversion factor. So I'm going to call this one number 1. Okay, and then in step 2, I'm going to be using this conversion factor right here. So this is my number 2. And this is my number 1. And again, you could write them right over the arrow, and now you've got everything you need to go ahead and set up your calculation. So let's do it. Okay, what I want equals what I have times what I know. And remember, what you know are your conversion factors. So we're going to set up our calculation. What I want equals what I have times what I know. So let's go ahead and do that. What I want is kilojoules of heat. Just make my pen line a little smaller here. There we go. Okay, and what I have is the volume of the iceberg. So that's 3.1 times 10 to the 13th meters cubed. Great. Okay, now times what I know. So this is where we're going to follow our plan. So here we are, we're in cubic meters of ice, and we want to get to kilograms of ice. And I said, well, that's going to require me to use this first conversion factor right here. 1 meter cubed equals 917 kilograms. And so when I put this conversion factor in, I'm going to make sure I put the 1 meter cubed in the denominator, in the bottom of my conversion factor, because I want to cancel meters cubed. So I need to divide by meters cubed in order to cancel those units. The other half, 917 kilograms, is going to go in the numerator in the top of my conversion factor. And right away, let's cancel the units that will cancel. Okay, now I'm in kilograms. So I have done the first step of my conversion. And then the next step, I'm going to go from kilograms to kilojoules. So I've identified that I need to use the second conversion factor that links those two units together. And again, I'm going to put it in to my calculation, remembering that I'm trying to cancel out of kilograms. So because kilograms is in the numerator here, I make sure that I put this half of the conversion factor, the 1 kilogram of ice, in the bottom of my conversion factor so that it cancels. The other half of that conversion factor, 334 kilojoules of heat, is going to go in the top. And again, let's cancel. Cancel those units that are canceling. So now, if I look at this calculation that I've set up, and this is always a great test to see if you set your calculation up correctly, the only units that I haven't canceled should be the units that I want. And they are. I've got only kilojoules left. What I wanted was kilojoules. So I know I've set it up correctly. I know I'm ready to put this into my calculator. So I go ahead and do that. So when you're setting up, or when you're entering these calculations into your calculator, you can multiply by everything on the top, divide by everything on the bottom. You can take it that approach, or we can kind of go from left to right. So 3.1 times 10 to the 13 times 917 divided by 1, which we really don't need to do. Dividing by 1 or multiplying by 1 is not going to change the value. So it's a step that we could skip. So going from left to right, then I've got my first number here times 917 times 334. Again, I don't need to divide by 1, but it's not going to hurt you to do that. And in the end, what's our answer? What do we get? So my answer comes out to be 9.49, and I'm not too worried about significant figures at this point yet in Chemistry 11, so it's okay to have it with 2 decimal places here, or 1 or 3, that's okay. Okay, we're going to learn about sig figs a little later. 9.49 times 10 to the 18th, and what are my units? Kilojoules, and I could even say of heat. That's how much heat is required to melt the iceberg. Double check that you are getting this answer with your calculator. If you're not sure how to use your calculator to write a power of 10, then let your teacher know. You can also look online to the brand of your calculator and search scientific notation with your calculator online. You might be able to get some help as well. But it is very important that you know how to enter a number in scientific notation and that you can calculate the correct answer. There's also a review lesson in this course that deals with how to work with numbers in scientific notation and how to use your calculator. And that review lesson is in this unit, in Unit 2, so go ahead and do that review if you're having any difficulty with your calculator and scientific notation. So that's the answer for Part A. And we set up our plan, we unpacked our question, we set up our plan, and then we followed our plan, canceling the units as we went along, and then in the end we had the correct units for what we were trying to calculate.